You must have observed the boiling of water. So when you heat water, it changes into the gaseous form. That is, it changes into steam. How does this change of the liquid state to the gaseous state change take place? Let's see. As we provide heat energy to the particles, that is, we increase the temperature. This increase in temperature or this extra heat energy changes into the kinetic energy of the particles. As the kinetic energy of the particles increases, so does the speed of the particles. So increasing the heat energy of the particles increases their kinetic energy, which in turn increases the speed of the particles. Let's see how it takes place. So you have the liquid sample. As you provide heat to the sample, that is, you give heat energy to the sample, the temperature increases. This heat energy changes into the kinetic energy of the particles. As the kinetic energy of the particles increases, the speed of the particles increases, due to which they move away from each other. That is why the interparticle space between the particles increases, which in turn leads to a decrease in the intermolecular forces of attraction. They overcome the forces of attraction of the liquid form, and therefore the liquid state changes into the gaseous state when heat energy is provided to the liquid sample. Let's see again how this boiling or change of the liquid state to gaseous state takes place. So we provide heat energy to water. That is, we are increasing the temperature of the sample, which in turn increases the kinetic energy of the particles. As you increase the kinetic energy of the particles, the speed of the particles increase. This increase in speed leads to a greater interparticle space between the particles of matter, due to which the interparticle force of attraction decreases. And this leads to the liquid changing into the gaseous state. So this is how a liquid changes into the gaseous state, or this is how boiling or vaporization takes place. Let's see what is the boiling point of water. So the water is boiling. We bring a thermometer to check the boiling point of water. So you see it is 100 degrees Celsius. So the boiling point, it is defined as the constant temperature at which a liquid changes into the gaseous state at the atmospheric pressure. These temperature calculations are made at atmospheric pressure because with the change in pressure, these temperatures like boiling point, melting point change. Therefore, at the atmospheric pressure, the constant temperature at which the liquid changes into the gaseous state is known as the boiling point of the liquid. Okay, what happens if you have a boiling liquid, say you're boiling water, and you bring a plate and cover the vessel with that plate? You'll observe tiny droplets forming on the plate. That is, the vapor, the water vapor or the gaseous form of water again changes into the liquid state. It forms the liquid droplets. Or at times, you must have seen the liquid droplets formed outside a very cold bottle of water. Why is this condensation or the change of the gaseous state into the liquid state take place? Let's see. So when we provide heat energy to the particles, their kinetic energy increases, and this increase in kinetic energy increases the speed of the particles. Similarly, if we extract heat energy from the sample, that is, we decrease the temperature, that decreases the kinetic energy of the sample, and as the kinetic energy of the sample or the particles decrease, so does their speed. So a decrease in kinetic energy leads to the decrease in the speed of the particles. So let's see how condensation takes place. So we have a gaseous sample. As we cool it, that is, we are extracting heat from the particles. So when we extract heat from the sample, the kinetic energy of these particles decrease. As the kinetic energy decreases, the speed of the particles also decreases. This in turn leads to a lesser interparticle space between the particles. As the space between the particles decreases, so the intermolecular force of attraction increases. This increase in intermolecular force of attraction brings the particles close, and so the gaseous form changes into the liquid state. So let's revisit how condensation takes place. So when we remove heat from the sample, that is, we decrease the temperature, we are decreasing the kinetic energy of the particles. As the kinetic energy of these particles decrease, so does their speed. And now the particles move with a lesser speed, so the interparticle space between the particles decreases. This in turn leads to an increase in the interparticle force of attraction, and so the gaseous form changes into the liquid state. Let's see how it happens. So here we have a liquid sample. We provide heat to the sample. As we provide heat to the sample, the kinetic energy of the particles increases. Therefore, the speed of the particles increase. So the interparticle space between the particles increase. The intermolecular force of attraction between the particles decrease, and therefore the liquid changes into the gaseous state. Now let's say we have this gaseous sample. We extract heat from this sample. So we cool it. As we cool this, we are extracting heat from the particles, so the kinetic energy decreases. This in turn leads to a decrease in speed of the particles. The interparticle spacing between the particles decreases, and so the intermolecular forces increase. And so the gaseous state changes into the liquid state. So when we provide heat to the liquid sample, as we heat it, the change from the liquid state to the gaseous state is known as boiling or vaporization. When we cool the gaseous sample or we extract heat from the gas changes into the liquid state, and this is known as condensation.